DPOS350P new oscilloscope from FNIRSI. 350 MHz bandwidth and 1 GHz/s sampling rate. Here are the two oscilloscope input channels. This is the output channel of the signal generator. First, we switch the language and click on the System Settings language setting item. Set the language to English. Then in the configuration settings, save this configuration as configuration 1. Let's change the configuration to configuration 1. After the setting is successful, each mode will be in English. Then you can set the automatic shutdown time here. The default is to shut down automatically after 1 hour. You can also turn this option off. Here is the factory reset and format disk. Here you can restore factory settings, format disk, system calibration. It is already set at the factory. Let's look at this place. Waveforms can be saved. The current waveform will be stored in the device. The screenshot function. The current screen display content will be completely captured. Click on the file to view. You can see a picture here. This is a picture we just saved. Click on the waveform to view the waveform we just saved. The waveform can be zoomed in and out to view. At the same time, we can connect through the USB here. Transfer the waveform and screenshots to the computer. In the function options, the brightness of the waveform can be adjusted, and color temperature display, and background grid display and hiding. Oscilloscope. First we can adjust the time base. Click on the left to zoom out, click on the right to zoom in on the timing. The current time base, it will be displayed here in HOR. We slide left and right on the screen. The waveform can be offset left and right. Vertical adjustment. In this position we can click CH1. Channel switching is possible. Click the plus sign to enlarge this vertical waveform. Click the minus sign. The vertical waveform can be reduced. Zoom in and out vertically. Now we slide up and down on the screen. You can change its vertical offset. Next is channel control. You can see, here you can open or close a channel. At the same time, you can select a magnification for this channel. Now it's DC, can be switched to AC mode. Here you can turn on the fast Fourier mode. Bandwidth limitation can be set here. The default is full bandwidth 350 m. When dual channel is enabled, the bandwidth becomes 150 megabits per second, because their bandwidth is shared. Suppose we need to capture the waveform, but I won't set up the oscilloscope. We can click on Automatic. It can capture periodic waveforms with one click, and stably displayed on the screen. We have two options when we need to measure. The first is manual measurement. You can see that the frequency of this waveform is 1 kHz. The period is 1 millisecond. At the same time, we can make vertical measurements. You can see that the amplitude of this waveform is about 1 volt. Of course, if you don't know how to measure manually, automatic measurement. To display the parameters, you can see the following line. These are the parameters of channel 1. We change the trigger to a separate item. Can better help you to trigger this waveform to capture the waveform. There is also a magnifying glass mode. You can zoom in on a certain position of the waveform. You can observe the waveform more carefully. In the upper right corner we can pause the waveform. It is convenient for us to observe. This button can center the waveform with one click. It is convenient for us to observe. Assume that the trigger level is not set. We can also click on this 50% to adjust the trigger frequency to the 50% position with one click. When the signal amplitude is very small, for example, only 50 millivolts of waveform, we can see that it has a lot of burrs. If you need to view this waveform accurately, you can turn on high resolution mode here. This is the effect of 8-bit resolution. It has a lot of burrs. Increase the resolution. The burrs are gradually getting smaller. By 16 bits, it is already very smooth. When adjusting the waveform at the same time, you can click Move in the lower right corner. Switch between coarse and fine-tuning. In fine-tuning mode, you can slide the waveform slightly. Coarse adjustment mode can slide the waveform by a large amount. When you want to observe the difference between two waveforms, we can turn on XY mode. Click here to center the waveform. Now it's a straight line. Switch waveform. Its graphics will also change accordingly. This is the signal relationship between the two waveforms. Now change its phase and the shape will rotate. This oscilloscope also supports 50M full function waveform output, maximum is 50M. VPP maximum is 5 volts. And there is an offset option. Duty cycle is only effective for square waves. We set the frequency slightly lower. Connect the input channel, CH1-CH2, and the output channel, GEM. You can change its waveform. The waveforms are relatively standard. Here you can capture a section of its waveform, output. That is, the chopped wave output. We intercept the downward part of this triangle wave. Perform output, click Save. In the File view, click on the waveform to view, click on the waveform to view. Click to cut wave output. You can see that this waveform is the waveform just captured. The oscilloscope uses time as the horizontal axis, level is the vertical axis. But the spectrum analyzer, this is the graph obtained by the oscilloscope after Fourier transform, it is based on frequency. Amplitude is the vertical axis, decibel microvolt is a unit of the vertical axis. It can be achieved by combining the horizontal and vertical axes. You can see directly from this graphic. What is the current highest frequency signal? Here you can set up automatically. This graphic can be displayed stably. This location has a reference. It determines the signal strength range on the display graph. If the reference value exceeds the reference value, it will be displayed as a positive value. Otherwise it will be displayed as a negative value. Attenuation means attenuating the signal, the process of reducing the amplitude of a signal. Make sure the signal does not exceed the maximum processing level of the analyzer. The starting frequency refers to the frequency at which the spectrum starts scanning. The end frequency refers to the frequency at which the scan is completed. The middle frequency refers to the middle value from the start frequency to the end frequency. The middle frequency here is 213K. You can also set the function here. FFT length setting can be set to 4K or 8K, or 16K, 32K. We choose 16K here. There is also a waterfall chart in the function options. The frequency accounts for the largest proportion of the frequency, displayed in red. You can also open 3D images. You can see the part with the largest frequency. It is displayed in this shape. There is another function in the function setting, frequency response meter. Through this output interface, output signal to the object being measured. The object under test then outputs a signal after the response. Back here through the two probes of the oscilloscope. Normally, there will be two lines here. The blue line is the phase frequency. The change in phase with frequency, usually measured in degrees. This yellow line is the amplitude versus frequency, usually expressed in decibel gain. Float value, which refers to the level output from this interface. Offset, refers to the output interface. Output level up and down offset value. Here is the starting scan frequency. The minimum is 100 Hz. Start scanning from 100 Hz. The maximum cutoff frequency here is 50 MHz. That is to say, the scan reaches the 50 megabyte position. The frequency base determines the fineness of the scanned waveform. Finally, the measurement mode. Next to the pause, this is the measurement mode. Single measurement and cyclic measurement can be selected. Open loop measurement. You can see that this waveform will keep changing. The measurement results may vary slightly. Single measurement. The waveform will be paused after one measurement. You can see that the current waveform has been paused. Finally, if you need to manually measure the relevant parameters of this waveform, you can open the cursor here.